This is a continuation from yesterday. It's pretty brief, just a few slides here. Just a few more examples of how we use this circular function where we're wrapping angles past that first quadrant. I talked about this yesterday, but let's officially put it in our notes. It says we can use blank to find the trig functions when the angle is not in quadrant 1. We have to use reference angles. Reference angles. Just means we're going to be drawing triangles. Remember, you always drop it back to the x-axis. Let's look at number 1. We know the sine value is going to be 3/7, and we know the tangent of theta is going to be less than 1. We want to find... Oh, we don't specify what we're looking for. Okay, we'll just pick something out. Let's see if we can draw it and we know what's going on. All right, first of all, let's go ahead and draw your axes on this. And let's figure out where this is going to be. If the sine of theta is going to be 3/7, remember that sine is going to be the opposite side over the hypotenuse. Okay, so I'm going to use those to help me draw my triangle. But this is going to be kind of important. Here's the deal. If sine is a positive 3/7, I know that it's going to have to be up here or up here because sine values are negative in these two. But then I'm not sure which one of these to use. That's what this piece of information is for. It says that the tangent is going to be less than 0. In other words, it's going to be negative. Of these two quadrants, where is tangent negative? Well, it's in this quadrant. Between the two of those, I should be able to identify what quadrant it is in. And then I'm going to just, and I don't get super picky at drawing this perfectly. I'm just going to draw it out here someplace. Drop it back to the x-axis always, and put theta at the vertex. Okay, now, if that's my theta, remember that sine is opposite over hypotenuse. Once you have opposite and hypotenuse, you can do a little bit of Pythagorean Theorem to come up with your missing side length. I'm kind of to the point where I do my Pythagorean Theorem in my head. Maybe you do too. It's going to be 3 squared plus something squared equals 7 squared. So I'm going to end up with a 49 minus 9. That's 40. The square root of 40, because I square root both sides, is going to end up 2 square root 10 for that side length. Now, it doesn't specify here. I don't know if they're wanting me to, I forget what I had meant for on this. If I have to find all of the trig functions, maybe that's what you'll have to do on your homework. Maybe they'll just ask for 1. Let's just do 1 for now. If you can find 1, you can find them all. Let's say we're looking for cosine of theta. What would your cosine of theta be? Well, here's the deal. Hang on, before I get ahead of myself. My triangle isn't quite right. I have to, when I look at my reference triangle, because I drew that over there in the second quadrant, I still have to pay attention to what sign, S-I-G-N, everything is. Well, my 3 and my 7 were both positive, because I'm up, and my hypotenuse will always be positive. But looky right here. When I snuck in this 2 root 10, I'm going left 2 root 10. That's really a negative 2 root 10. And there's nothing that they gave me to indicate that. I have to know that based on what quadrant it's in. That's important because I'm going to be looking for the cosine. And the cosine is adjacent over hypotenuse, and the adjacent happens to be a negative 2 root 10 over 7. And then I can find the others just as easily. Let's practice again. Set up your axes. Now, the secant is a positive 3. Now, secant's always going to match what cosine is. Cosine is your x. X is going to be positive here and here. And then I'm going to use this to distinguish which of those I want. Well, the sine is the y, and it has to be positive. That's going to have to be up here. Go ahead and draw your triangle then. It's going to fall up in this quadrant, drop back to the x-axis, and put theta here at the origin. The secant value, well, I don't know my secants, but if my secant is 3, then I know my cosine is 1/3. And cosine is adjacent over hypotenuse. Adjacent is 1, hypotenuse is 3. That's 1/3 for the cosine. And then do a Pythagorean theorem. Again, it's going to end up being a 9 minus a 1. That's a square root of 8, 2 root 2. If you have to write out your Pythagorean theorem, then you do that. Now that I know all three sides, do you think anything should be negative here? Nope, I'm in the first quadrant. Everything's positive. And again, the hypotenuse will always be positive. It's only your opposite and adjacent that you have to worry about whether they're going to be negative. Let's look for a tangent, I guess. Tangent of theta is opposite, that'd be 2 root 2, over adjacent. Oh, that's 1. I picked an easy one, didn't I? I don't even have to rationalize or anything. All right, the last one's yours. You give it a shot. Pause the video. That wasn't very nice. I gave you kind of a weird one, didn't I? Okay, so cotangent is undefined. Recall from our unit circle that tangent is undefined along your y-axis. It was kind of like slope. Remember, undefined on vertical? And here it's 0. Well, cotangent's going to be the reciprocal of that. Cotangent is going to be undefined along the x-axis. Okay, secant is going to match cosine, so I want my cosine negative. That's going to happen over here. It needs to fall on this one. All right, and then I didn't tell you, we should have agreed. I don't know, let's do something trickier. Let's do, what do you want to do? Cosecant, maybe? What's the cosecant of theta at that spot? Well, it's a weird one. I'm over here. I know that's where it falls. Cosecant matches sine. The sine is my y value, and it looks like I'm not up anywhere there, so that would be 0. And the reciprocal of 0 is undefined. Okay, we're going to do a few more applications. That's kind of an important piece of trig, is to be able to draw those triangles and apply a real-life scenario with that right triangle. On this one, we have a survey standing 50 feet from the base of a large tree. They measure the angle of elevation. How tall is the tree? This is a review question. Do you remember how we did this the other day? It's been a few days. I'm going to let you give it a shot. See if you can draw it out and make that happen. Pause the video. All right, here's mine. Do you like my tree? I put a big squirrel hole in it. Do you remember that when we were little, you put a big squirrel hole in the tree? I've never seen a squirrel hole in a tree, but that's what we did when we were little. All right, set it up. It's basically just like a previous problem that we've had. One of the things I wanted to catch you in, or not catch you, but make sure you remember that this is in degree mode. If you aren't getting that same answer, maybe you're in the wrong mode, so be sure to check that. All right. Let's try one more, a little bit trickier. Let's go ahead and we'll do this one together. A person can see a river directly ahead, and rather than walking through, there's a typo there, through the mud directly to the river, the person walks 400 yards along a 30-degree angle to the river's edge. How far away was the river initially? All right, so let's draw a picture. Here's the edge of the river. We got that. We've got our person down here. And he would like to walk straight to the river, but it's muddy. So instead he's going to walk along this line that is a 30-degree angle to the river's edge. So it's more like here, where we're walking, where this is a 30-degree angle. And he's going to have to walk 400 yards that way. The question is, how far away was he from the river to begin with? There's your x. All right. Finally, this is one that's not using tangent. We use a tangent a lot with these types of problems, but since I know the hypotenuse, I know it's not going to be tangent. From the 30-degree angle, I know the hypotenuse. I'm looking for the opposite. That should be sine. Sine of 30 is equal to the opposite over the hypotenuse. I am in luck because the 400's in the bottom, I guess, if that's lucky. Take in your calculator the sine of 30 and multiply it by 400. Looks like he was 200 yards. Oh, well, heck yeah, you know what? Sometimes I get so caught up in doing the math, I don't use my brain. If you have a 30-degree angle, isn't this a 30, 60, 90 triangle? So I could have just known, okay, well, this is my short leg, and the short leg is half of the hypotenuse. Did you catch that? Good for you if you did. Okay, that's all we've got today to add in. Good luck.